Okay, can you see the screen?
Yes.
Yeah. So today we have two items. First one is Shankar going to do a demo actually for the external Kubernetes CA integration with Istio and RA. The second one will be flexible authorization policy presented by Yang Min. Yeah. Let's start with the first one. Shankar, are you ready?
Yep. I just need to
feel free to switch your video.
All right. Yeah. Okay. So the goal of this demo is to basically find a very specific way to integrate with an external certificate authority. And this has been discussed in a couple of RFCs. So there's an RFC that was written a few months back, which talks of the different ways of integrating custom CAs. So in this demo, we'll basically be using the Istio as an array and to integrate with the CA. So the question is, what is an array? So when the workloads issue the CSRs, during boot up time, when they issue the CSRs, they send the CSR requests to Istio. And Istio essentially ensures it verifies the identity of the entity presented in the CSR. So that's essentially what the array does. And once it does that, it basically forwards it to the CA for signing. In this case, we're assuming that the CA trusts the array, which is Istio, and pretty much signs any CSR that's given by Istio. Now, to talk to the external CA, we actually rely on the Kubernetes Csr API. So this is actually documented on the Kubernetes page. So this is an API by which you can actually send CSR requests to the Kubernetes cluster. And from Kubernetes 1.18 onwards, there is a mechanism to forward these CSR requests to an external signer. So I'm highlighting this here in the signer name. Now, one such implementation of this is actually has been provided by it's provided by Cert Manager. So this is kind of an experimental operator that's developed by the Cert Manager team. And essentially what they do is they listen to the Kubernetes CSR requests, and once it's been approved, they sign it and send it back. So to start with the demo, I have when you guys get a chance to go through this, it's actually fairly detailed. It talks about how to build the CA and how to deploy the CA on the Kubernetes cluster. So in my cluster, I actually have the CA running. So this is the namespace where the certificate authority is running. And as you can see, this is the deployment. Now, this CA is actually listening for any certificate signing, any CSRs that are sent to this particular signer name. Here's a second. Okay. Yeah. So it's actually example.com/foo. So anything that is sent to this particular signer name is picked up by the certificate authority. So in the Istio system, the Istio has a couple of changes in the configuration. So I just want to take you through that. These can all be configured using the operator. Firstly, there's a new environmental variable called external CA, which tells Istio that don't sign the certificates using Citadel, forward the CSRs somewhere else. And in this case, it sends it to Kubernetes. Just ignore the spelling of Kubernetes, that's a typo. And then we also tell Istio which signer that we want to use. Now, the idea behind this is that you can have multiple certificate authorities deployed in the cluster for, some may not be used by Istio. So you want to direct it to a very specific certificate authority, and that is actually indicated here. Now, one important thing is whenever you have an array, there has to be a mechanism by which the CA can essentially authenticate the array, either explicitly or implicitly. Here, it's important that the service role of Istio has been given permission to send CSR requests to this particular signer, which means that although the CA is deployed in the cluster, not every entity running in the Kubernetes cluster can actually send can communicate with the CA, because you need to have the service account has to be bound to a cluster role that allows you to use the signer. So that's kind of how we ensure that only Istio is using this CA. And then we have a couple of other parameters which are not really that important. So let me quickly go through the demo. So right now in the default workspace, we don't have any workloads running. And I will basically, so this is the standard book info example that I'm deploying. Right. So yeah, so you can see that all the workloads are now running. And if for most of you familiar with the book info example, there is a product page which kind of diverts the HTTP call, which sources the data from multiple backend services. So yeah, so this is now, I'm talking to the ingress gateway deployed on my local cluster, and this is now talking to all the backend services. Right. So one important point to note is what is the nature of the secret that has been deployed. So let's take one of these workloads, and yeah, so let's just copy the name. Right. So if we look at what are the certificates that are used for Istio mutual MPLS, so these are actually the secrets. This is the certificate chain, and this is the root CA. So if you look at the certificate chain, let's just decode the certificate chain here. 64 decoding. So it basically presents a certificate chain. Let's look at the last certificate on the chain, the root CA. So if you decode this, you can actually see that it's been signed by the organization is Jetstack, which is the private enterprise that supports Cert Manager, and the organization. So all this is basically, this corresponds to the CA certificate of the external CA. So to actually double confirm that, let's now go into the namespace of the external signer. And let's look at the, yeah, so let's look at the signer CA. So the signer CA has the, this is the TLS cert corresponding to the external signer. So decoding. And, yeah, let's present this here. So you can basically verify that the external CA is using this as the root cert. So we just confirmed that the certificate that has been retrieved by the proxy has been signed by the external CA. So there's a fair bit of configuration. There's not too many configurations, but there is a couple of configurations that are needed for Istio to be able to interact with the external CA. And for 1.8, there will be a task that basically gives you the configs in the Istio operator to be able to do this. For example, we have to specify the external CA. We have to first specify that it's an external CA. We have to specify the signer name. And we also have to we also will mount the root CA certificate just to validate that the cert has been signed by the correct CA. So yeah, that's kind of the end of the demo. So yeah, I'm opening it up to questions.
One quick question. Does Kubernetes spec now require that signers include the full chain? Because that was a problem before, that there was no clear way to. I mean, I know cert manager happens to put the chain, the full chain when it signs, but
no. In fact, I am in. Because it was not done, one of the requirements in the config is that you load the external CA cert just to vet the root CA cert, just to verify that it's signed by the external, just to verify that it's signed by the correct external CA.
I mean, programmatically, the problem is that Istio needs to programmatically include the full chain. It doesn't work if we don't include the full chain. So it's not about verifying, correct. It's about automating. So basically, you're saying that if a signer happens to follow the pattern that cert manager is using, which is to include the full chain, we are good.
Correct.
Okay, that's good to me.
Correct, yes.
But the Kubernetes does not. I mean, if you use it,
I know it does not. It does not.
Good.
Yeah. And in fact, if I'm not wrong, even the Kubernetes signers, like the legacy Kubernetes signers themselves, don't include the cert chain. We actually have to dig in and we have to append the cert chain through a not very straightforward mechanism. So yeah.
But that's deprecated anyway, so it doesn't matter. And the second question is, in the previous 2 or 3 meetings ago, someone demonstrated cert manager integration with direct path, I mean, agents to cert manager.
Yes.
Now that we have 2 ways to integrate with cert manager, which one should we recommend? And I think
so. This is a good question, and I specifically wanted to touch upon this. So I think the real question regarding this is how exactly is the CA expected to verify the identity of the entity present in the CSR? It's all dependent on this. Now, for example, so if you're doing it by yourself, so if you're not using an RA to do this job for you, that means that the burden is on the CA to first of all validate that the identity is correct, right? Now, this is what I believe the cert manager team has done. But even in order to do this, they are actually leveraging our authentication libraries to actually verify that the identity is correct. So they've actually plugged it in. Now this is fine. So essentially, this requires the CA to using some mechanism, they have to validate the identity of the person presenting the CSR. Now this is possible for if the CA is actively in development, right? However, if you're using a legacy if you're using private CA, for example, which is a Google product, they are not going to extract they're not going to validate the identity in the CSR. So in these cases, you have to go through Istio D, because in this case, the explicit assumption is Istio D is checking, verifying the identity. So
no argument here. I mean, if you have to go to Istio D, you should go to Istio D because you have no choice. But if you have a choice, like cert manager, I think normally you would prefer the direct way. I mean, if cert manager does have first class support for agent, we should recommend them to use the agent, even if
there's only one small thing. The only additional thing that I have with this is this code, which we use to authenticate the identity of the sender of the CSR request. It changes quite a bit. So now let's say we move into Istio 1.9, right? Now let's say they are running a cert manager corresponding to 1.8. Then we're going to send them some new token which they're not going to be able to understand. That's the only concern that I have, because it requires the CA authentication libraries to be compatible with what Istio is running at a given time.
I think they need to be compatible with Kubernetes, not with Istio. And I think the Kubernetes APIs have been stable for quite a while. And also they are switching to OIDC. So I think any CAs that supports OIDC will be probably okay. The SPIFFE verification is a different story. But and given that we officially said that that interface is defined, we kind of are expected to treat it as an API and maintain it. I mean, token type. Especially since Google Managed CA is using the same, protocol basically. So it's kind of very unlikely to change without us noticing. And
got it. Okay. Yeah. So I think. Sorry.
Yeah. I have a few questions. So is this in 1.8 or is this going to be in 1.9?
This is in 1.8.
I see.
Yes,
So,
but it's experimental.
okay. Yeah. So, but users can use it in 1.8, but they need to configure some flag to opt in, right? And this is an experimental feature.
Correct.
Thanks. The other question is, so what happens when for example, the cert manager is done? So what happens after that? Or it cannot like issue the certificate or something like this?
So there isn't any standard mechanism. I mean, right now we're treating it as though Citadel was down. So there's no mechanism that's in place currently to deal with this. I'm open to suggestions on how to deal with this, because I mean, you can't expect, because I don't know if you want to have a backup CA. If you want to have a backup CA, that's not a very straightforward approach. It's not the right thing to do in my mind. So what would you suggest regarding this?
I do not have suggestions, but I'm just curious, what do you do for now? So I guess when the cert manager is unable to sign certificate, we will just treat it like an internal error. So the pirate agent doesn't get its certificate, right?
Yeah. So essentially, the new workload, whoever is requiring this certificate, will not be able to join the mesh.
Which is normal.
I see.
So just a couple of things regarding this. So I think the main goal of this was, with any custom CA integration, was to integrate with a CA which would not have private keys in the Kubernetes cluster. I think that's the main reason why people are tending to gravitate. So the example that I've given is, the cert manager, which is running in a different namespace, is still maintaining local keys, but they do have an implementation where I think they maintain the keys off cluster, I believe. So hopefully this is being recorded.
Maybe the Vault integration would be a better example.
Yes. Yeah. So correct. Vault is there, but even through this, but Vault, I think we don't use the Kubernetes APIs. We directly talk to Vault. Here, so in the signer Venafi, what they do is the CA controller just extracts the CSR request from the cluster and then sends it to Venafi, and Venafi signs it with its private keys that are outside the cluster. So,
sorry, you said that we added support for Vault in Istio. I thought we are not. We are going to go through this path.
We are not.
We're not.
Yeah.
So
the API will be Istio API.
Sorry, I meant Cert Manager has integration with Vault. And
right.
With your work, we also have integration through Vault by Cert Manager. So that will be external.
Correct. And that's what I'm pointing out, is that this is the one, actually. It's not with Vault, it's with Venafi. So they have a sample code which essentially does this. So
I think they have both.
I think they have both. I think the one that they demoed 2 weeks back was with Vault, and that uses the Istio Csr Api API.
Yeah, both of them work in both ways. Yeah.
Correct. Yeah. Right. That's exactly.
That's good.
Yeah. So
for the control plane, I have a question. For the control plane authentication, you are still using the Kubernetes CA as the issuer, right?
No, we don't use Kubernetes CA. We're using right now. We're using Citadel in open source.
Yes, we're using Citadel, and I will fix this with the PR. Yes.
Got it.
I think the argument here was we don't want an external CA to be issuing workload certs and the Citadel issuing the DNS, the control plane.
Right.
So that I'll fix this in the PR.
Okay. So basically, you mean that you'll use Cert Manager to this signing API to generate certificates for it. Yeah, that's perfect. That's what we wanted. And that will mean that also Vault and whatever root CA will also sign both the DNS certificates for Istio and the certificates for Gateway, I suppose, no?
Yes.
We have, yes, it's implemented, or yes, it's planned?
So when you say the gateway, are you talking about the external facing part of it, or the part?
We now moved John moved the SDS server in Istio. So Istio is also handling certificate requests. So if you ask for certificate for example.com,
yeah,
normally that goes today through Cert Manager to the their own API. So
Okay.
they create a certificate request with example.com, and then Acme is called. So I'm wondering if this will also be used to integrate Acme signing and other things.
This is I've not tested this, so I have not tested this for Windows right now.
But it's fine. I mean, we can use the standard their standard API.
Right. The only additional thing I wanted to mention is that because the signer name as an attribute in the Kubernetes CSR request is only introduced from Kubernetes 1.18, this will require you to run Kubernetes 1.18. So that's a bit of a limitation, because I think that's bleeding edge of Kubernetes. I'm not sure how many people are running this, but yeah, that is a requirement, because otherwise we can't direct the CSR request to an external signer.
Yeah, I think that's fine. This is the experimental, and also we are next step we are going to implement their integration model based on their Istio CSR API. That will solve this problem.
Right.
Okay.
Right.
Do we know? I was looking for their code from the demo, and it is in some branch. Do we know if they have any plan to release it? Anyone from Cert Manager around? Or?
Oh, are you talking about the previous demo, the one that was given 2 weeks back?
Yeah.
I talked to him on Slack. I am not sure if they're planning to release it. I'm not sure about this.
I mean, the experiment. I found the branch, and it's right release to build, but it's not something that it's included in their official release yet.
Right, and in fact, even these, the ones that I've demoed so far, are not in their official release as well. But the hope is that if given that there's a lot of community interest in external CA, so if you even want to integrate it with some off-the-shelf CA, you can just the code is fairly easy to extend, the ones that they have written, because the bulk of the code just interacts with Kubernetes and then just signs it. So you can just extend the signer part to talk to whichever CA that you want to.
It would be good at least, for 1.9, for example, or even for 1.8, if they can to have a release of Cert Manager that includes the support, so we can start more testing for users.
Right.
That's the point of experiments.
Right. Sure. I'm welcoming any inputs on this, and I think the next step, as Oliver mentioned, is to provide a sample implementation or an adapter with the Istio Csr Api API.
Cool, thank you. Let's go to the next topic. Yami, are you going to take over?
Yes, I can present. So basically, I want to bring up the follow-up discussion on the flexible OC policy we discussed sometime earlier about how we want to enable the reject support. So I think we have some valid concern that this might be even very unlikely break some existing users if they are already using this spatial syntax in their policy. So after considering this risk, we now prefer to make this feature opt-in, which means users, they have to manually configure some flag or specify some annotation to opt-in and enable this feature. And before they do that, the whole string will it will not be interpreted as a regular expression. It will be just an exact match. So currently we are considering two main options here. The first option is that we just introduce a global flag that can be set as part of the pilot environment, environmental variable. And when that flag is set to true, we will start to interpret this syntax and treat the remaining part as a regular expression. The other alternative way is we can introduce a per resource annotation. so that each resource you can, each authorization policy resource, you can put an annotation saying that, hey, for this resource, I want to enable the regex syntax. And then you can use the regex syntax, and we will interpret the reading part as the regular expression. So that's the two main options we consider. Currently, we more prefer the global flag because it's it makes the policy more consistent, and it's easier to write your policy. So you do not need to worry about the annotation, because eventually the annotation itself is kind of becoming the API. And it will be a little bit hard in the future to remove that annotation. But if we go with the global flag, and we can then have more time to advertise this feature and get more feedback. And at some point, maybe 2 or 3 versions later, we can change this behavior to be opt-in by default. And the user, they do not need to change their policy because of like we are like removing this flag. But if we use the annotation, they will need to do some cleanup in the policy. So we want to bring this up in the community meeting and see if there are more feedback on this. And one thing to note that this is going to be in 1.9, so it will not be in 1.8. We will have some more time to hear the feedback. That's all. Oliver, are you here?
Looks like he dropped off. He had said that he was going to halfway through.
Yeah, that's all I have. So any questions?
It makes sense to me, and I thought your logic for making it global made sense, but I mean, I'd be curious about other people's opinions, but to me it all sounded good.
Yeah, thanks, Justin. Yeah, thanks, Justin, for bringing up this valid concern. I think it totally makes sense. Yeah.
Yeah, it sounds good to me too. Yeah.
Yeah, thanks, Mimi. Yeah, I think then I guess that's all for today's meeting.
So these are the only 2 topics we have, right?
Yeah.
Okay. Yeah, so if there are no other topics to discuss, I think we can end the meeting earlier.
Great. Thanks, everyone.
Yeah. Thanks all. Bye.